session, okay, even if we have tutorial session, but at the same time, I also give you some theories, and then after that we go for few exercises. Okay, same goes to lecture session. Okay, for each topic, okay, we learn about, and then we go for a few exercises, right? So today we will cover on first chapter, first topic, which is about introduction, a bit introduction on differential equation, ordinary differential equation. Sometimes I will call ODE or DE, ODE, okay? But all of them are same, okay, about ordinary differential equation. Okay, before that, if not mistaken, Lim Kian An, the one who texted me yesterday or last 2 days. Am I right?
Yes, madam.
Okay. For your information, your brother's module, that one used since 2021 or 2020, before 2020. Am I right?
Yeah, I think so, madam. Yeah, 2021 like that.
Because based on my review, okay, that module use as the name of that module engineering mathematics 2.
Yeah, yeah.
Yes, because I also have that one, but quite confusing. I'm telling you, you still can refer, but quite confusing because the yellow one that we use now, okay, the yellow module, we have a proper topic. That one, the topic, sometimes you need to go to chapter 2. After that, few topics that we not cover. All right. So I would like to suggest, if you can buy that, the new one, the latest one, okay, you can buy this, or up to you. Okay.
Ah,
Uh,
okay, madam.
that one use, uh, I'm not sure. The last one is about 2020, 2020, 2020 or 2021. I'm not really sure. Okay. All right.
Thank you, madam.
Okay. Class, hopefully you can allow me to off camera so that maybe sometimes internet quite slow, okay? Hopefully it won't affect our session, okay? All right. Sorry, now I'm trying to connect my tab to join our team. Okay, for your information, your attendance already recorded uh after this online session, and so automatically your attendance will be appear, okay, on my Teams. So I don't have to create a Google form for you to fill up. Okay, before that, anyone here international student? No one. Okay. You know what? Sometimes I can um use Malay also. Boleh nampak? Okay, this is ordinary differential equation module that we will use throughout this semester. Okay. Okay, for the first chapter, okay. So at the end of this topic, student will be able, okay, you should be able to the first one, solve first order differential equation using suitable techniques. Okay,
Madam,
and then, yeah,
I can't see your slide.
can see a white or
It's
that's why
only there's
ah,
only black screen there.
oh, black screen, confusing. Right. Okay, now
Okay dah.
sekarang okay I think macam
Nampak.
not sure lah. Teams ni quite takes time sikit lah. Dia delay kan. I'm not really sure. Previously, saya punya screen semua putih since you said that you can see. So, I just ignore. Right. Yang the yellow page ni, you dah dapat tengok tadi
Dapat.
Okay. Right. Thank you. And then the second one, you should be able to perform calculation of first order ODE using maths tools. So maths tools kita ada project, yeah, and then you can should be able to perform good teamwork. Okay, in this course, not only to give you information about what is ODE and so on, but we are trying also to um, train you, to work in a team, right? So perform teamwork in solving first ODE problems. So differential equation. Kelas kak. Akak meeting dulu Saya masuk lepas kelas. Sorry. Okay, differential equation. So a differential equation is an equation with a function, okay, and one or more derivatives. Okay, what is derivative? Derivative, okay, is not a function. Is a kind of dy over dx, or y prime also derivative. Okay, y double prime also derivative. Y double prime is d squared y over dx squared derivative, meaning that pembezaan. Ada pembezaan. So, an equation dan a function, okay, with a function n1. So, function is y, derivative is dx dy. Okay. Okay, it's already mentioned here. So, we solve it when we discover the function of y or set of a function of y. Set of a function y plus 2y plus y squared and so on, okay? But it must come with at least one derivative. That is a differential equation. Right? Class, if you have any question, you can interrupt. So, a differential equation has significant grouping, which are ODE and also partial differential equation. Okay, we have two types differential equation. The first one ODE, the second one partial. Okay, so ODE with a single independent variable such as y. Okay, we have dy over dx, d squared y over dx squared, d to the power of n y, dx to the power of n. Okay, or we can also write as y prime, double prime, and y n, y to the power of n. Okay, so partial differential equation is an equation or differential equation with two or more independent variables. So we have y here, After that, we have U. Okay, so it has 2 or more. So in this case, it has dy over partial. This sometimes people will use del, okay, del y over del x. But actually, the correct one is we need to use a full name of this, which is partial differential of y, okay, over dx, okay, over del x. So it has y and u, and it can be more than 2 different, independent variables. Okay. So in real world, things change. Okay. Okay, real world things change. Maknanya bila ada suatu perubahan, and describing how things change and how to describe the change of that things. Okay. This leads to differential equation. Alright. And then this module focus on ODE only. So you don't have to worry about partial differential equation because this course only focus on ODE. Yeah. So this classification is based on derivatives, and another classification based on the order and degree of differential equation. So class, in differential equation, we have 2 terms classification. Order and also degree. How can we see that differential equation, it has what is the order of that equation and what is the degree of the differential equation? Before that, may I know, is anyone here already watched the video for section section 8? Have you watched the video?
Belum habis.
It's okay because it is actually the same, okay, with what I'm telling you this morning. Okay, the same as previous one. Okay, so don't worry, the same thing. Again, order. So the order of ODE, order. So for example, if you have differential equation, so dy dx, for example, function y plus dy dx. So what is the order of the equation? So the order of ODE is highest derivative in the equation. So, and then how about the degree? Degree is highest power of highest derivative. Okay, if you look at here, the order depending on highest derivative. After that, if you look at the highest derivative, and then if the highest derivative has power, okay, so the highest power, okay, the first thing you need to look at highest derivative. After that, look at the power of highest derivative. The highest power here is the degree. Okay. So look at example 1.1. So for A, dy over dx plus y square equal to 5x. So this is differential equation because we have derivative, one derivative here. So what is the order? The order of this equation is first order. Okay. Right. Additional information here. Okay, first order, but it hasn't mentioned about degree. But if I'm asking you about degree, what is the degree for the question A?
First degree.
Yes, first degree, because the highest derivative is this dy dx. So it has first order, and then the degree of this is 1. So if we want to write in complete way, so we can write first order, first degree ODE. Okay, first order, first degree ODE. Okay, if we want to write in complete way. Okay, look at B. So B here, look at highest derivative. So highest derivative here is 2. Okay. So this is second order ODE. How about its degree?
First degree, Doctor.
Yes. Is there any answer? Second degree? No, because second order, this is the order. Okay. Highest derivative is D squared, highest derivative, so second order. But when we mention about degree, you need to look at what is the degree here. Degree is 1. So second order first degree. Right? So C, it has first order, third order. So for if we look at the order, the highest derivative is 3. So 3 with so this one is third order, ODE, and then the degree is 1. Right? And then D, the highest derivative here is 1. Look at D, D here. So 1, and then okay, the power of this is 2. So order, first order, degree is 2. So first order, second degree. How about E? First order, second order, third order? About order.
Third order.
Third order.
Yes.
Order.
Third order. Third order, degree?
First degree.
First degree.
First or second degree?
First.
Why first degree, not second?
Because the degree is depend on the highest power of highest derivative.
Yes, because degree, you need to look at highest derivative. Highest derivative is third order here. So third order, first degree. Okay? Okay, very good. So far, do you have any question, class? Kalau tak ada, kita tengok next. First, okay, this is this answer just now for E. So 1.2, first order differential equation. So the simplest ODEs to be discussed are first order, okay, ODE, which involve only the unknown functions, first derivative and first derivative and no higher derivative. Okay, first derivative only. Okay. The concept of solution, a function, let's say you have a function y equal to fx, y equal to gx, for example, x equal to fg. As long as function, normally we use y, y equal to fx. Oh, my screen freeze.
Doctor.
Already go to the next page. Sekejap. Itulah saya pun monitor from my laptop. That's why I verify with you. Memang betul lah. Tak faham. Dia masih freeze kat situ. Sekejap, I stop sharing. Okay. Dah okay? Nampak? Page 3 Nampak tak?
Nampak doktor.
Okay. Thanks. Okay. Just now the answer ni third order. And then first ODE, differential equation. So the simplest ODE to be discussed here adalah first order ODE, which involve only the unknown function first derivative, no higher. So first order ni kita akan lihat tentang first derivative sahaja. Kita tak cover higher. So the concept of solution, a function y equal to fx. Okay. Normally we use y lah. Y equal to fx. Sometimes you can find the function based on your tengoklah. Okay. But in this case kita banyak guna y lah. Okay, y equal to fx is called solution of a given ODE on some open interval a and b. So if fx is defined and differentiable throughout the interval. So for example, you have a function, okay, apa-apa function, okay, a equal to 2b for example, okay. So it's called as a solution untuk any differential equation, okay. Differential equation is something that in real world you have changes, okay, changes in terms of suhu, okay, okay. Temperature in a classroom, for example. How can you know, okay, if the temperature outside and temperature inside the classroom, okay, and then how the controller can control between outside and inside classroom, how to maintain the classroom's temperature. It uses this differential equation, okay, so that, for example, of course, inside the sensor itself, it has a solution. So the solution meaning that a function that can solve the changes. For example, outside. So what happened actually in the sensor? So outside temperature, for example, 30, one inside the classroom 25. So it has a derivative, okay, ODE, okay, differential equation. So based on that differential equation, it has a function that can solve that differential equation in order to maintain in the classroom's temperature. Okay, that is one of application, simple application, for example. So something that always changes, and then you need to find the solution. So that is about differential equation. So don't it's actually what can I tell you? Every single things in this world, okay, we have maths equation actually, but how we can relate, okay, the function and what we have in our real world. So it depends whether it uses differential equation, calculus, and so on. Okay. And then, for example, here, so a function is called a solution of any ODE. Okay, as long it has interval. Okay, so maybe you can have more ideas when you go for your project. So example 1.2, for example, verify that y equal to COX is which C is an arbitrary constant or random number. Okay, is a solution of ODE. This is a function. Okay. For all x not equal to 0. So you have a function x, y, not function, ODE. X, y squared equal to negative y. So we want to know whether this function can solve or not for this differential equation. So there is few steps. The first one, you need to differentiate y equal to c over x, to get y prime. Not this one. This is based on this y and then get y prime. And then, but in the end, after you differentiate this, you can relate. So this equation, if you can get the same with y, xy prime equal to negative y, so it verified that this is solution for ODE. So the first one, differentiate. So if you differentiate this, what you get? Okay, so differentiate y prime equal to, so C, you have one, sekejap. You have y equal to C over x. It is actually C dot 1 over x. Also same with cx negative 1. Okay, so y prime equal to C and then negative 1 x negative 2. So this become negative C x negative 2 negative C over x to the power of 2. Okay. So that's why you get the answer. I hope you still remember how to differentiate equation. After that, you have another steps. Okay. The first one, differentiate. After that, integration. You need to integrate. Okay. So please, I'm sure you know, but maybe some of you forget. Okay. So we play around with this differentiation and also integration throughout the subject. Okay, after that, you need to multiply y prime by x. Okay, y prime here. So you multiply by equal to xy prime. So this one, okay, so y prime and then you multiply by x. So these two, you can cancel out. That's why you will get negative c over x. Is it clear or too small for you? Boleh macam kecil, terlalu kecil, takut you tak perasan degree and sign of negative tu. So, kemudian step ketiga, substitute equation yang diberi kepada number 2 ni. So substitute. So xy prime, kita dapat xy prime, substitute negative y. So we know that c over x equal to y. Yeah. So you substitute. So here become negative y. And then you need, after that, you compare with the given ODE. If you compare with the given ODE here, so dapat sama. Okay. Bila you dapat sama, after you substitute, bila telah gantikan tadi, dapat sama. So it is verified that verified that y equal to c over x is the solution for this ODE. Right. Okay. Now, go to example. Okay, verify that y is a solution of the given ODE here, for example. Okay, so do you have pen and paper with you?
Yes.
Ada, Dr.
Okay, quiz. Takut tak? Okay. Oh, alamak kelas. Di session saya terlupa pula record. Okay. Tak apa. You can also refer yang previous class. And then it is very simple introduction. So tak berapa nak berat sangat. Okay class. We go for exercise 1A. We go the first one A. After that we go for B. Okay. And then test 1A. Yeah, man. Exercise 1A. A. Soalan dia adalah verify that Y is a solution of the ODE. Okay, A, Y equal to CE negative 4X, and then its ODE Y plus 4Y equal to 0. So solution so differential equation Y prime. Okay, and then Y. So the first step, you need to find what is Y prime. You need multiply with X. Third, substitute the given equation into number 2. Okay, so we go for the first. So first one, Y prime, you have Y equal to CE minus 4X. So Y prime you dapat berapa? How to differentiate exponential C? So how to differentiate this one? So this is exponential function, so you need to write it back exponential negative 4x. After that, you need to multiply with the differentiation of here. So differentiation of here is negative 4. Okay. And then y prime equal to negative 4c exponential negative 4x. Have you got the same with my answer?
Dapat, Dr.
Okay, y prime. After that, the second one multiply with x. So you have y prime equal to negative 4c exponential negative 4x multiply with x. Multiply with x. Okay. Then after that, substitute. Okay. So you have xy prime equal to negative 4c exponential negative 4x x. negative boleh lah 4C exponential. Sabar ya, siap. X, okay. And then based on equation here, C exponential negative 4x is equal to Y. So C exponential here is okay, Y equal to CE negative 4x. Okay, based on the given equation, right? So xy prime equal to negative 4yx. Then you can cancel out. Okay, with that you compare. Always compare. Here is y prime plus 4y, so no x. So at the same time you can cancel this x. Then what's left? Y prime equal to negative 4y. And then you move 4y to the left equal to 0. So here is verify. It is verified that is the solution for ODE. Okay. Dapat sama Okay. Then we move to B. B y prime y equal to
Madam,
here.
for the question A, I did a different solution.
Different solution.
Madam, is it compulsory for us to multiple the y prime with the x for the second step
For the second step, multiple.
with x? Is it compulsory?
You need to write x. X here.
Yeah, I mean, is it the step? Is it? It is a must for us to multiple with x, because
Yes.
what I'm doing is I just substitute the equation of y prime and the equation of y into the y prime plus 4y equals to 0.
Oh, you straight away using the first step, and then after that you straight away go to the third step.
Yeah. Then I
Okay.
substitute y with the equation above, the cx
First equation.
something. Yeah.
Meaning that you just continue negative 4y straight away. After that, you
Yeah.
go to y prime plus ini. Okay. Actually, this is step that compulsory if in your test or in your final exam, if you don't have these steps, so this will be, you maybe lost 1 or 2 marks. Okay. This is step provided by to a verification. Okay. So only step, but I know that you understand. But for the steps, what steps you will lose 1 or 2 marks based on question given. But still, because it shows steps. Otherwise, if you look at the answer, the marks only 2 marks, maybe you can move to this straight away. Okay. Who asked me just now?
Chan.
Chan. Okay, Chan.
Understand.
可以
Okay.
Alright. Okay. Manan. Okay. Because this is a very simple equation. Okay. Why does this module provide all these steps? Because in your test and also in your final, the question not as simple as this. That's why you need to get used with the steps. Okay? Because it is very simple. And then we go to the next. Y equal to C exponential negative 2.5 x square. And then the solution, ODE is y prime equal to negative 5xy. So solution okay. The first one, so what y prime here? Y equal to C exponential negative 2.5 x square. So that y prime equal to anyone? If you get your answer and then please share with us.
Negative 5 C exponential negative 2.5 x squared.
Any
X.
other answer? Apa? X. Oh, ada X. Any other answer? Okay, I hope everyone get the same. Okay, this one correct. And then after that multiply with x, xy prime equal to negative 5c exponential negative 2.5 x square, x square. Okay, here you have c exponential 2.5x, where is y, so that xy prime equal to negative 5yx square. So you can cancel x with this x, so y prime equal to negative 5yx. So it is verified. Okay?
Doktor,
Yeah.
kalau dekat Y prime tu kan, after dah differentiate, X dekat belakang tu letak dalam bracket ke? Kalau tak letak dalam bracket, acceptable ke?
Boleh. Bukan apa, sometimes bila saya buat, kadang saya pun tertulis, saya tengok pun your test ke, your based on my experience nanti ada tulis exponential negative 2 5x kuasa 2, nanti ada yang x kuasa 2. Kan, kadang-kadang dia yang ini, kadang-kadang dia tertulis ke atas tau. Kadang-kadang saya macam kuasa 2 ke atas ke, kat 2 ke, macam ni kalau kuasa 2, kalau x saja ada x lagi ke. Kadang dia macam in term of penulisan, tapi okay, without bracket also betul jugalah. Betul. No problem. Cuma
Okay,
tulis tu kan cantik-cantik lah sikit. Sometimes ada orang tu ada tulis U tu ada 4 macam gini, ada 4 yang macam gini. U ke 4 ke? Tulisan kan pelbagai. So ini cara saya menulis lah supaya macam memang tak, supaya you refer back later, okay, you will not confuse. Sometimes saya tulis pun ada kadang-kadang ke atas ke bawah. Normal tak apa. Okay, kita boleh go to the next. Separable ODE. Okay, ada question tak? 5, 4, 3, 2, 1. Okay, tadi baru tak ada, saya laju je. So, let's look some different types. Nanti you may try for C and D. Okay. Other types of ODE and how to solve first order by separating variables, homogeneous ODE, linear, exact, and power series method. Okay. These are methods that we can use to solve ODE. Okay. However, how to use separating variable, it has its own technique, meaning that you need to verify whether the equation suitable or not. That's why dia ada macam mana kita cakap is bukanlah cakap method dia ada sesuatu that you need to identify before you go for each method. So the first one, we look at separating variables. Sometimes we call it separating variable, separation equation, okay? But it's all about separate, right? So for separable, ODE, practically useful, ODEs can be reduced to the form of, okay, this one, if you have differential equation, okay, you have a function. So then this actually try to tell you about the steps. Okay. But the main point here, okay, I don't want to go detail in this, might confuse you, but the main point here is the variable. If you find out x and y in the equation, in the given equation, whether the equation, make sure the equation must be differential equation, because now we are in differential equation, okay? So make sure differential equation and the function, okay, in the equation can be separate for its x and y. So meaning that can separate on each side, okay? So y, you can separate y to the left hand side and x to your right hand side. If you can separate y and x so that you can use separable equation. Okay. Example 1.3, solve ODE y prime equal to 1 plus y square using method of separating variables. For example, if you get an open-ended question, so it says that solve ODE using suitable method. So if you try to use separation variable, so you need to make sure you can separate your x and y on different side. Okay? So the step number 1, rearrange and separate x and y. Let's look how this can be separated. Okay. Just now, equation is y prime equal to 1 plus y squared. So in this equation, we don't have x and y, but you need to remember y prime is dy over dx equal to 1 plus y squared. Right? This one. After that, you can separate. So this 1 plus y squared, you move here as denominator. Denominator in a fraction, okay, pembahagian, kita belah atas, kita ada numerator, yang bawah denominator. Okay, numerator, denominator dalam satu-satu fraction ataupun bahagilah. Okay. So dx move to the right, so you can separate. Now, if you look at the equation, your y on your left, your x on your right hand side. Then we go to the next step. You need to integrate both. Integrate both sides here. Okay. Okay, dy integrate 1 over 1 plus y squared dy. So how you get arctangent? Let me stop presentation here. So for this, okay, it has integration of 1 over a square plus x square dx equal to 1 over a arctangent x over a plus c. This is the mean. So since you have right now integration 1 over 1 plus y square dy equal to, so 1 over, your a is 1, arctangent y over a is 1 plus c. That's why you get arctangent y plus c. Okay, this one. Why C1 and C2? Because C1 for left hand side, C2, okay, integration of dx equal to x plus C2. And then class here, for example, arctangent here, y equal to x plus C1 minus C2. These two are constants. Okay. If you minus C1 to C2, a constant, so you will get another constant, x plus c. Still a constant. So that's why, sorry, this is arctangent. Arctangent. Here arctangent y equal to x plus c. So arctangent, you move to the right, it's become tangent. So if you look at the equation, if the equation you get with the answer with a constant, okay, and you have C, for example, a constant A based on the equation or question, or if you create your own letter, okay, A for example, but this constant equation with this constant, we call it general solution. Okay. Okay, then initial value problem. Initial value problem, what is the function of IVP here? IVP here is to help you to find what is the value of your constant. See here. Okay. Normally in a question, okay, if you being asked to find particular solution, the question must give you IVP. Otherwise, your solution is only up to general solution, which is in form of C here. If IVP, this is IVP, is given so that you can find up to particular solution. Because of what? Because in particular solution, you can get what is the value of your constant here, so that you can get your particular solution. Is that clear, class?
Clear, Doktor.
Pagi-pagi apa? Kering sikit, Kak. Kosong-kosong, Okay. Alright. Now, about initial value problem. Okay. When initial condition given, a function of y when x 0, x naught, okay, initial, you will get y naught. So the answer for that function at 0. Okay, with a value of x naught and y naught, okay, is inserted into general solution, the value of arbitrary constant, a constant c, can be determined. So by substituting this particular of C, a particular solution will be obtained. So that is the purpose of initial value problem. Initial value, So Based on definition 1.7, an ODE with initial condition is called initial value problem in the form of y prime will equal to a function of f as y, and then initial value given as y x naught equal to y naught. So this is called initial condition with y equal to y naught when x equal to x naught. Okay. Solve example 1.4. Solve y prime equal to dy over dx equal to 3y with initial condition y0 equal to 5.7. Check ya. So this example, the first one, you need to rearrange and separate x and y because this is under separation variable. Okay, so separate. Step 1, separate x and y. So since dy dx equal to 3y, so you can separate. This become y on your left and x on your right hand side. Okay, and then step number 2, generate general solution. Generate general solution here. Integrate both sides. Integrate. Integration of 1 over 3y is 1 over 3 ln y. Boleh dapat siapa tak tahu boleh bagi maklumkan. Okay, integrate x. Integration dx dapat x. Okay, again kat sini it's supposed to be 3 ln y plus c equal to x plus c. This one c1, c2. So this move to the right. So 3 ln y equal to x plus c. Okay, where c is c1, c2 minus c1. Okay. So ln y you will get, so 3 here you move to the right, ln y equal to 3 times x plus c. So 3x plus 3c. Apply exponent on both sides. Okay. Apply exponent. Okay, class, why should we apply exponential here? Why don't we just leave in ln y?
Nak dapatkan y tu, doktor.
Yes, because we want in term of y. Initial condition given in term of in form of y, and then differential equation in form of y. So we want to use y in term of y. So okay. So this one belah atas ni, so kita boleh pecahkan. So exponential ln y, we get y. So exponential here. Exponential 3c is a constant. Because how can we know that is a constant? Because in this exponential, it has no y or x term. Okay. So that is a constant. So in this case, it uses a. Never mind, if you want to use a c equal to exponential 3c also, fine. Not a big deal. So, in the end, you will get y equal to a exponential 3x. This is general solution. Why general solution? Because you still don't know what is the value of this a. So after that, since general solution given y 0 equal to 5.7, so you need to apply y0. So here x equal to 0. Okay, x naught. Here is y naught. So 5.7 equal to a is, we don't know a but exponential 3 times 0. So you will get exponential 0 is equal to 1. Okay. So a equal to 5.7. Then in the end you will get y equal to 5.7 exponential 3x. No more constant, meaning that unknown constant here. So that is a particular solution, right?
Doktor,
Next, yeah.
minta tolong terangkan apa e power of ln y tu dia jadi y. Saya tak ingat.
Oh,
Exponential ln y jadi y.
exponential y jadi y. Kena buka balik calculator log ni. Buka balik calculus. Okay. Exponential dengan ln dia macam saya tak ingat dia punya betul-betul log Exponential is log dia bukan log Sekejap ln ni log 10/10 kalau tak salah saya. You check balik lah, you check calculator. Kalau you try exponential of ln 2, you will get 2. Check balik your calculus.
Okey, doktor.
Ni calculus ni, calculus. Bila you datang sini, saya pun ingat tak ingat dia punya log berapa tu kan.
Okey, doktor. Saya check balik.
Alright. Okay. Try je calculator exponential ln tu dapat tak tu. Semua ada calculator ke depan? Tak ada.
Ada, madam.
Dah try?
Dah.
Dapat? Dapat tak?
Dapat.
Kan? Guna cara ni kan?
Ada.
Nanti next week you boleh share. Kawan-kawan. Okay. Apply. Dah habis kan? We go to exercise 1B. Right. So, kita try to look at Q2A. Lepas tu saya akan kasih lagi satu contoh buat ni Q2A. So the question, solve the given separable ODEs, show the steps of derivation beginning with general solution. Okay. Saya takut nanti apa yang saya bagi semalam tu tak sama dengan awak semua kan. So Kosong. So this is a differential equation. This is the solution. Okay. Solution, sorry, initial condition. Okay. So solutionnya, the first one apa? Separate kan? So x dy over dx plus y equal to 0. X. Apa? X dy. Before that, I know whether most of you ni di lepasan mana? Poli ke?
Differential doktor.
Oh, UTSM. Okay. Boleh tak dapat? Kelas? Macam mana tu? Ada yang dah dapat? Boleh bagi saya jawapan awak? Anyone?
Tak ada apa doktor.
Apa dia? Awak cakap apa tadi, Hafiz?
Saya tak dapat sebab saya ingatkan kena separatekan y ke kiri x ke kanan. But bila saya pindahkan x ke kanan, macam kosong pula.
Oh gitu.
So saya loading.
Okay, maknanya terstop kat situ lah. Ada yang dapat lagi lain?
Kalau x per dx sama dengan negatif y per dy betul ke?
Maknanya x per dx sama dengan
Negatif y per dy.
negatif y per dy. Boleh juga, tapi kalau y sebelah kanan? Tak habis
Kalau
lagi.
y sebelah
Kanan.
tak tahu lah. Tak kat situ madam.
Lagi? Tak. Kenapa saya tanya ni? Sebab saya cuba nak membantu, nak melihat kat mana yang you lemas. So that macam saya kena slow down sikit lah kan. Kalau tak saya laju bercakap aja. Alright. Yang ini sikit lagi. Cuba teruskan bawa y ke kiri. Lepas tu saya nak tanya. Okay. Ada tak awak jumpa persamaan perbezaan okay, y ni apa? dy dx. Dia kalau ada dy, dia macam d over dx y kan? Tetapi dia d dengan dx ni boleh datang together dx sebelah bawah. Tetapi kalau macam dx saja macam dia perlu berada di atas. Unless kalau dia datang dengan d over ataupun d over dy. Baru boleh dy ni dengan dx ni dekat bawah. Kalau tak, dia single je macam gini, dia bawakanlah dia ke atas. Boleh faham tak maksud saya? Dapat tak idea? In this case, kita tak ada d over dx, d over dy tau. Kita ada dx and dy saja. See, we have only dx and dy, so that please bring it, put it above. Boleh faham tak maksud saya?
Saya tak faham Doktor.
You ada dx dengan dy. Okay. Selalunya, kalau kita jumpa d over dx, katalah function apa-apa pun. Ni d dx baru y tau. Tapi sometimes kita tulis dy over dx pun betul juga. Okay, tetapi sebenarnya ni bukan tapi sebenarnya ia menggambarkan begini. Pembezaan terhadap y. Okay. Tetapi yang ini, dia hanya ada dx dan dy saja. Dia tak ada d yang atas ni. Okay. Bila dia tiada d ni, so bawalah yang ini ke atas. Sekarang ni, apa yang you buat, ni dekat bawah kan? Tetapi atas dia, tak ada d pun. D dx of x ni tak ada, tak wujud. Okay. Untuk membenarkan dia ada kat bawah ni. Jadi,
So kalau macam tu satu per y darab dy betul ke?
macam mana? Macam mana?
Negatif 1 per y darab dy sama dengan 1 per x darab dx.
Betul? Macam tu lah caranya. Okay?
Faham je.
Okay. Yang lain okey. Ataupun saya tunjuk cara mungkin satu-satu, cara mungkin berbeza tetapi pandangan macam cara awak mungkin cara saya berbeza, as long as you dapat jawapan yang betul dengan cara yang betul, tak ada masalah So, kalau kata yang macam gini kan, opening sangat, x dy plus y dx over dx sama dengan kosong. Ni maknanya ni darabkan dengan dx. Lepas tu, x dy tambah y dx sama dengan kosong. Okay. X dy sama dengan negatif y dx. So, dy over y sama dengan dx, negatif dx over x. So, samalah juga jawapan kawan awak ni tadi. Right? Sama je. Dia positif negatif kiri kanan tu tak ada masalah. Okay. Okay, next. Kemudian yang kedua, unit to integrate. Integrate 1 per y dy equal to integration of negative outside here 1 over x dx. Yang tak tahu boleh tanya. So integrate y 1 over y dapat ln y equal to negative ln x plus c. Make sure wujudkan c. Okay, again, okay, c is also include c on left hand side here. So combine it to the right, so it become c. So apply exponential because we want to get in form of y. So exponential ln y equal to exponential negative ln x plus c. Y equal to, so exponential ln x dapat exponential ln x. Negative ln x dapat
Negative x.
berapa? Tekan kalkulator. Exponential negative ln x. Okay, exponential negative ln x adalah negative 1 over, sebut negatif pula. Tak negatif. Okay, 1 over x. Multiply exponential c. So yang ini I put as c. So y equal to c over x. So c over x here is your general solution. You ada kelas ke pukul 10? Saya padam
Ada doktor.
Ada. Laju sikit lah. Sekarang pukul apa? Oh, lagi 10 minit. So lagi satu soalan. Kita laju sikit ni. So apply IC initial condition. So y4 equal to 6. So y4 equal to 6 meaning that from you have y equal to c over x. So 6 equal to c over x is 4. C equal to 24. So you will get y equal to 24 over x. So this is your final or particular solution. Okay. Tengok saya punya 4 pun dah macam you. Macam ni kan. Okay. Alright. So I would like to go to the next example. Okay. X to the power of 3 dy over dx equal to 2y. Okay. Initial condition given. Y1 equal to 1 over exponential 1. Okay. The solution. Okay. The first one, separate. Separate so that y go to the left hand side, x right hand side. So you will get 1 over y dy equal to 2 over x squared dx. Up to you. You can have also 1 over 2y on this side also can. Okay. Right. And then, okay tak ni? For the first fraction, boleh dapat? Kalau you dapat cara lain pun okay. Sebab dua ni is just a constant. You can put here and then but this is remain 1 here. So integrate 1 over y dy equal to integration 1 over x cube dx. So you will get ln y equal to 2. Okay. When you integrate 1 over x to the power of integration. Integration here 1 over x cube is equal to integration of x minus 3. So x minus 3 and then you will get x to the power negative 2 over negative 2 plus c. So that you can cancel this. Ln y equal to 1 over x square plus c. So after that, apply exponential. Exponential ln y equal to exponential. Okay. Exponential 1 over x square ada negative in front. Okay. Ada negatif kan? Okay. Negative plus c. So y equal to exponential negative 1 over x square exponential c. This become c. Y equal to c exponential x square. So this is your general solution ataupun GS. Yang ketiga, apply IC initial condition. So y1 equal to 1 over exponential 1. So here when x equal to 1, y equal to exponential 1. 1 over exponential 1. So from general solution, you have y equal to c exponential negative 1 over x square. So 1 over exponential 1 equal to c exponential negative 1 over 1 square. Right? So here c equal to 1 over exponential 1 multiply exponential negative 1. Ni bukan 12 tau. 1 to the power of 2. So over exponential 0 equal to 1. So y equal to 1 exponential negative 1 over x squared. So y equal to exponential negative 1 over x squared. So this is your particular solution. Boleh tak? Laju ni saya bagi. Okay? Boleh? Dah diam dah. Masuk kelas lain ke dia?
Masih
Okay kan?
masih mencuba doktor.
Okay, nanti you refer ni You check balik, mungkin agaknya kuis saya bagi nanti, bukan kuis macam ni, saya bagi kuis-kuis yang macam mana nak buat differentiate, macam mana nak buat integration ke, mungkin lah kan. Sebab saya lihat macam mungkin ada sesuatu yang awak semua dah lama tinggal, mungkin dah lupa lah. Okay. Kelas ni semua lelaki ke? Lo Ihan ni lelaki perempuan?
Tu lelaki doktor.
Lelaki.
Wah,
Betul
saya dah
lelaki.
satu. Saya, tak boleh, saya kena stop record. Kira saya lah satu-satu bunga kat dalam ni.
Saya doktor.
Ada? Ada? Mana yang perempuan?
Saya.
Saya tu siapa? Kenapa tak keluar nama?
Jasmine.
Jasmine. Oh, Jasmine Nur Natasha. Okay. Okay. Ada satu bunga di kalangan apa selain daripada saya ni. Saya dah tak saya dah bunga-bunga makcik. Okay, alright. Siapa lagi? Seorang je perempuan. Tak apalah, nanti Jasmine become my best friend lah kat dalam ni.
Boleh doktor.
Okay, dah dapat. You all ada kelas ni. Saya pun tak nak kacau lah kelas lain. Okay, I will share. And then actually, if you compare to the previous notes that I've shared for section 8, sama je. Saya tengah fikir macam mana mungkin selepas ni, based on my experience, bila saya share pada tutorial yang pertama, and then tutorial kedua ada additional information yang mana section sebelum ni tak dapat tau. Jadi saya rasa mungkin selepas ni saya dah habis kedua-dua sesi tutorial baru saya share my notes. Sebab kalau ada yang section 8 tak dapat tu, dia boleh refer yang ni lah. So far untuk section 8 dan section 9 sama saja notes dia. Ni saya tulis ni. Okay, kelas, kalau tak ada apa-apa, nanti refer saja yang saya ada share kat dalam files tu. Sama saja dengan apa yang saya tulis hari ni. So, kalau tak ada apa-apa, we dismiss this class. See you next week on hari Selasa. Okay. Thank you. Bye. Assalamualaikum
Terima kasih,
warahmatullahi wabarakatuh. Sama-sama.
Thank you, doktor.
Thank you, Doctor.
Thank you, doktor.
Welcome.
Thank you doktor.
You're welcome.